Hi, are you ready to answer the question that everyone's a bit too afraid to ask? Let's find out how to use ChatGPT without getting caught. And to do that, we'll start from scratch. So you don't need to know like any programming or nothing at all. We're just gonna try to understand how the systems to detect AI generated text work, which is actually the key to know how to get around them. So, are you ready to uncover the mysteries? Thanks a lot for joining. We're gonna have three parts in the talk, but I'd say that if you really want to get into like the interesting part, so that's the real answers, you could just skip to this part here. So the circumvention, that's gonna come around like minute 20 something. So if you wanna just get answers and that's it, you can like just skip to that part. But like if you want to understand everything, I'd say stick with me for a little bit, and we are gonna be understanding, well, how the detection works, which explains the rest of the presentation. So up to you, but I really suggest that you stick for the first 20 minutes, kinda. And the first of the things that we need to know is what are LLMs. So like there's lots of ways to like explain this thing, right? But in the context of this presentation, we just care about the fact that LLMs are text predictors. So it's like, you know, like when you're writing like a text for someone or something like that, like your keyboard is like predicting the next word all of the time. So it's just literally that. So an LLM just completes the text all the time. Something like this, you see, like it's writing the next word or the next part of the word all the time. That's an LLM. That's what we need to know here. And the only difference between like ChatGPT or something like Bard, Claude, etc., and your phone is that ChatGPT is, let's say, intelligent, like it's a big system, lots of parameters, etc., and your phone is something small, something less intelligent, but the way that they work is the same. They just write the next word all the time. So that's what we need to know in this presentation, and that will help us to understand the common techniques that exist to detect generated text. And we're going to be speaking about 4 techniques, but actually just 3, you'll see why. And the first of them is something super simple. So like I'm just gonna really go over this part very quickly. The first thing is a classifier. So a classifier is just a thing that tells us, yes, it's human, or yes, it's generated. No, it's not generated, so it's human. How do we do that? We just give lots of examples to the system, and we hope that the system will just know somehow how to, well, figure out like if a text is generated or not. There's an interesting system that was created by OpenAI to detect generated text. And if you go to their website, you see here, like this is the OpenAI website. And in January 2023, so that's last year, they created, or well, they launched this website that just gives us an error right now. So why am I showing you the website then? It's because like they discontinued the system because they said our classifier is not reliable. People are like trusting our system, but actually like it doesn't really work. So that's one of the things about classifiers. They are not, we should be aware that like they tend to, well, make mistakes, and specifically the OpenAI one, it's not very good. That's why, yeah, they just retired the thing. But it also raises some questions, like your OpenAI, you created a chatbot that like writes answers and people are using it, but at the same time, you're not able to create a system that really works for detecting the things that you are creating. That's more about ethics and those things that I just don't have time to get into, but well, it raises questions, right? I don't know. That's just things to speak about like in a different talk. But I'd love to mention another thing, which is Ghostbuster. Ghostbuster is just another system to detect generated text. You see, like I get some score, etc. It's better than the OpenAI classifier, which could be accessed anyway, like its own Hugging Face. So like if you search on Google Hugging Face, OpenAI classifier, something like that, you could still use the system. But this one that I'm showing you right now, Ghostbuster, better. It's just better because like they just take like lots of different metrics to train a normal classifier, and well, it's just like come out pretty recently, like some months ago. It's state of the art, so I'd say if you want to use a classifier, this is the one you should probably consider. And it's a good system, works fairly well, and yeah, it's state of the art. So that's for classifiers, the first of the systems that I wanted to like just have a note on. And just for the sake of time, let me move on to the second type of systems, which is the second type of analysis. That is a thing that we call black box analysis. However, as I said before, we're going to be speaking about not 4, but 3 systems, and that's the reason why. We're not going to be really speaking about like black box analysis, and that's just because this type of analysis is not very effective today. Like, it's kind of outdated, you could imagine. Like, it's not the best tool that we could use right now for detecting generated text. So let me just skip over this part to speak about white box analysis. And well, to speak about white box analysis, I think that the best thing that I could do is just show you how it works. So let me show you this tool that's called gltr. Okay, that's a website. You can search for it, and it's this one here. So here we are, gltr. I'm gonna pick like like a sample text. So for example, this text, it was written by GPT-2. And what we see here is that like we have an analysis of the distribution of the probabilities of each of the words or parts of words in the text. So for example, if you look into this word, so I've been a gamer for over 10 years during, and then we ask the system, what do you think comes after this word here? The system tells us, I think that probably the next word is that. If it's not that, then it should be those, this, my, the, etc., etc. So it's giving us a distribution of probabilities of the words that the system thinks that should come after the first bits here. And that is is a great way to see if the system would write this text. So if we see lots of green things as here, it means that the system would have written this text, because like all of the words are things that the system thinks that should go here. And that is something very different from a human text, because if we take an example from like a real text, we see that the system is very surprised to see things like learned facts or represents or structure, GAN here. Those are words that GPT-2 would have never written. If we see a text with like lots of colors, probably the text is human. Now, we're going to take a look at like an evolution of this thing that is called detectgpt. And that thing is like probably the #1 result that comes up, like if you just search for detect AI generated text, something like that on Google. What's the thing that, or like the twist that detectgpt does? I love to use an example to explain that thing. So when I talk, I tend to use like a lot. Like that word, I really use it like a lot. So if you see a text that contains like a lot of likes, probably it's my text, right? Like you would say that the probability that that text is mine is very high. But if we take a text that I spoke or wrote containing lots of likes, and we change the likes in the text by another word, so like, for example, we take the likes and we just write okay instead, or like another word, right? Like we just change the word, then we can do this thing that's called, well, just a perturbation, and we take the score of the perturbation and the original text. So the original text, the text with lots of likes, will have a super high score for being my text. However, the rewritten text, so the text that doesn't have any likes, probably will have a super low score. So the detector will not think that the system is, that the text is my text. So what we do is we take the scores of the original text and the rewritten text, and then we compare. The question here is, was the original text much more likely to be my text compared to the rewritten version? So if the answer is yes, then we conclude that yes, probably the original text was my text. And what we do with GPT or any LLM really is that we just take like a text, we do some modifications to the text, so we perturb the text, and then we take the score of the original text and the perturbations, and we compare again. If the text originally was written by an LLM, and then we rewrite the text, and it doesn't look like it's being written by an LLM, that means that the original text was written by an LLM. So that's how detectgpt works. Very interesting idea, very smart. And it's one of the state-of-the-art systems as well. Really, really good system. So that's detectgpt, but it has a problem. And it's a problem, I love this name, the capybara problem. I didn't come up with it, but I think it's a great name to describe something that is really important, which is that if I go to ChatGPT and I ask ChatGPT about something like rather strange, like something that people don't usually speak about, so like in this case, like a capybara that is like an astrophysicist, if I ask ChatGPT about the thing, of course I will get an answer about a capybara that is an astrophysicist. It makes sense, right? Because like I just asked about this thing. So we have like conditioned probability here for this thing being the answer of my query. It makes sense. The likelihood of this text, knowing that I just asked about this, is very high. It's probable that I would get this answer. When I see a text in isolation, so like, for example, like if I see a high school report or something like that, I never get to see the prompt of the user. So I don't know what the person asked ChatGPT, which means that if I just see a text without any context, it can be very surprising. I knew where it was coming from, so I understand that this thing is likely. So I can say, oh, it was written by an LLM because an LLM would likely write this thing when it's being asked to write about a capybara that is an astrophysicist. But if I just see this text and I don't know that it's been written by ChatGPT, then I would say, oh no, an LLM would never write about a capybara that is an astrophysicist because like it's, well, a super weird idea, and like an LLM would never imagine that this thing could be like a real thing, So it's very surprising to someone that doesn't know the context. That's the capybara problem, and it's a hard problem to solve. A group of scientists tried to solve pretty recently, like some months ago, and they came up with formula that I'm not gonna get into, but the idea is just to measure an idea that I think is very interesting, which is that, as we just saw like 30 seconds ago, something can be surprising. So if something can be surprising, what we do is that we normalize the thing by the expected surprise of an LLM on that text. That can sound confusing, so I'm just going to give you an example so we understand what's this thing. Let's take a text, right? Like the capybara text, that's confusing, or like that's surprising. We wouldn't expect to see this text just coming out of like an LLM. So the perplexity, the surprise, the likelihood of that text, or the unlikelihoodness of that text is very high. So we wouldn't expect to see this text. But why would we not expect to see that text? There's actually two parts of something being unlikely. The first thing is that in this case, this text is unlikely because it's unusual. So like the topic is something very creative, so we wouldn't expect to see this thing. But then another source of perplexity, surprise, is that the text is written by a human person. So when we write as humans, we use like some words that wouldn't be the top one choice for GPT, for example. GPT will be more surprised to see a human text than a machine text. And what we try to do is that we try to isolate these two parts of surprise. So we try to remove the part of the perplexity that just comes from the fact that the text is unusual. We remove this part, and that's what I said before, right? Like we normalize by the expected surprise of an LLM on that text. We remove the part of a text being surprising because it's unusual, and if we get to do that, what we're left with is that we have a measure of how likely is a text to be written by an AI. So that's what we do. That's the formula. We get a measure, and the measure that we get is a much better measure of how much is this text likely to have been written by an LLM. There's a ratio that they came up with experimentally, 0.85. If we get like a higher number, it's human. If we get a lower number, then it's AI. It's a great idea, really. It's a great idea, and this system can be tried online. I'm just not going to show it because it's basically the same thing as the other systems that we just saw, but it's a very smart idea and a very smart way of trying to get around the problem of the capybara problem. So that's Binoculars, really great system, came out very recently, so a really great system to try. And the fourth technique, and the last one I'm going to be talking about, is watermarking. So what's watermarking? Watermarking is just like something that we embed into a text, right? Like we put a watermark on something and that thing sticks into the thing, but we can't actually see it. So when we do watermarking with a text, we do a thing that's called a system of two lists, a red list and a green list. And to imagine how it works, like just imagine that I have like a dictionary here, and I start highlighting all of the words in the dictionary. So like the first word is red, second word is green, the third word is red, the fourth word is green. And after doing that with all of the words in the dictionary, I have a notion of which word is red and which word is green, right? I have two lists. One list is my red words and the other list is my green words. So what I do after that is that I just tell the system, you can never write any of the red words. If you write a red word, that's banned, so you can't choose those words in your distribution of probabilities that we saw before. You can't choose those words. That works great until we get to words that go together. So for example, Barack Obama, that thing has to go together, right? So what we do to solve this problem is that we just do a thing that's called weak watermarking in contrast to strong watermarking. And basically the idea here is that if you have two words that are like 99% likely to go together, then you don't apply this thing of the red and green list. If you have like a set of possibilities that look likely, then you do apply the watermark. That's a great technique, and it's especially great because it gets rid of the capybara problem. If we see a text and we see lots of red words, we know it's human. If it doesn't have any red words, it's very likely to have been written by an AI that was using the watermark. So it's a great technique, really. Very interesting. And those are the 4 techniques that will allow us to understand how the detection of AI text works. But I'd love to give you like some little tips on how to detect the thing, like just like using your, I don't know, common sense, I'd say. One of the things that we should be aware of is that looking into like the types of words doesn't really work. Like, well, LLMs tend to write kind of similarly to humans, so that thing doesn't really work. But if you think about other things like your writing style, if I don't know, let's say I'm 15, I'm supposed to write like a teenager, right? Like I'm not supposed to write like a PhD. So your writing style can give some hints of that person using like a chatbot to write the text. Also dialects. If I'm American, I don't write as a British person, so I wouldn't use British words. Also typos sometimes like can give you like a hint of, okay, that person like was writing the text. Or of course, like they could just like do it on purpose, but like these are just ideas, you know, hints, things that could help you to see like, well, like to get ideas. Also, hallucinations. If you see a hallucination, that thing is really the best hint that you can get. Like something that just doesn't look real, like something that you know is false. There's different types of them, but try to especially look out for things that just don't make sense at all, or facts that you know are not true, or bad math. So like when you're doing math and like the result is just incorrect. Those are very evident types of hallucinations, and it really can give you a great like hint on this text has been generated. However, human annotators are horrible, are really bad at detecting generated text. So you should really keep that in the back of your head. We are very bad at detecting generated text. So we can try to do it, but yeah. Will it work? Kind of complicated. This is the real important part, which is how to get around the systems. So what can we do to just evade the detectors of generated text? We've just seen how they work. So now it will make sense that we just need to do a very specific thing to get around them, right? And if I ask you, what's the main idea that comes to your head when like you try to get around them? Probably you'll tell me that what you have to do is paraphrasing or rewriting text or changing the words. So if you do this thing, if you just like take a text, change the words of the text, then you will arrive to a text, if you do it well, if you paraphrase well, you will arrive to a text where it can't be spotted anymore. This thing can be done manually. You can just rewrite the text yourself, or you can use paraphrasers. we'll look into that in a second, but the idea here is that if you paraphrase, you can really evade the detectors. In fact, how much can you like evade them? Well, here I have like a table where we had a system that was detecting text with a 90% accuracy, which is a lot, right? Like it's really great. But my question is, how much do you think it drops when we paraphrase? So like, yeah, like how much can we like reduce the accuracy of this detector that was working really well with like, well, a set of texts? Drops a lot. It drops so much that it basically becomes a coin. So a flip of a coin has a 50% chance of being correct, right? If we like paraphrase the text, we make the detector behave as the flip of a coin. So it means that it's not effective at all. It means that paraphrasing or rewriting is really, really the best thing that we can do, and it's really effective as a technique. We need to do it very well to be able to actually evade the detectors, because like it's not just changing 5 words, it's like really rewriting the phrases. But if we do it well, we can really evade those systems. And now I'm going to give you some tools that you could consider using if you want to rewrite your texts. You can just search for them in Google, really. Like there's new tools all the time, so like you can just search paraphrase text AI, something like that on Google, and like you will probably like just find all of these tools that I'm just gonna give you. But if you want some like names of tools, yeah, Grammarly is a good tool, AutoWriter, Go Copy, there's really like lots of them. And deepl, the one that we're seeing here, it's one that you have to use in Hugging Face, so the website. You like search for deepl, paraphrase, Hugging Face, something like that, and you'll arrive to a Hugging Face page where you can actually go and like put your text, get the written thing. T5 is another paraphraser that's hosted on Hugging Face, so you just go there, you write your text, and like you get the paraphrased version. And you can also do a smart thing, I'd say, which is you take a text, for example, like you text like a text in English, you translate it to French, and then you take the French translation and you translate back to English. And you should get some differences in the way that it's been translated, especially if the translator is not perfect. Then you should like just like, yeah, have changes in phrases, etc. So that's a way to write. But if you're gonna use deepl, there's a great tool, and that's the one I'm gonna show you right now, which is my favorite thing to write. deepl write. So you see, like you have the translator or deepl write, which is a new thing that came out pretty recently. And what's the great thing about this? The great thing is that it allows you to just select what you want as your rewritten version interactively. So I can say, I don't like opposition, I prefer resistance. Or instead of this, you should write this thing. You see, like you can interactively change the text, and that's the best way to really like do rewriting well. So if you want to rewrite, that's my favorite tool. Really go for any of them, but this one really, I'd say it's top notch. So deepl write, really great tool. Having said that, I'd also love to give you like some manual tricks that you can try to apply to just, I don't know, avoid being detected. And one of them is that you should give the system a lot of information about who you are. So you should tell the system, you should write as if you are a high school student that is, I don't know, like writing about the French Revolution, and you're like a student from the US, whatever, you know, like you give lots of information about like that person, you, and that way you will allow the system to write a bit more like you. Also, it's nice to use the active voice. You should try to ask for that, because like a lot of the examples that are given to these systems to train the systems are in passive voice. So that means, for example, 500 patients were used for this study. That's passive voice, that like in a scientific study, right? Like they use lots of passive voice. If you ask for active voice, not only does your text sound like, well, more personal, but also it changes the distribution of like the tokens, like the probabilities of the tokens. It makes the capybara problem a little bit worse. So if you ask for the active voice, that's a good idea to ask for. It's not going to change a lot, but like I would try to ask for this. Also, using very specific data. So if we go back to the French Revolution example, like just give like lots of data about like what you are asking about. It started this year. It lasted for this many months, and I don't know, like this many people died, etc., etc. As much specific data as you can, that will help the system to write a text that is much more surprising. Also, avoid quotes. I'm not saying to avoid quoting other people. What I'm trying to say is that you should try to avoid quotes like George Washington said whatever, like those phrases that like everyone says. You should try to avoid them, because when the system sees one of those phrases, it will see that all of the words are agreeing, because it's been seen 1,000 times already. So it will think that it's been written by AI, when actually it's not. It's just like a very common phrase, but it will think that it was written by AI because it's a thing that doesn't surprise the system at all. So if you want to not get in trouble, I would avoid using quotes like that. Quotes, and also legal texts and texts that appear in like lots of places. Just try to avoid them. Another great thing to do is to just outline the structure that you want. First, I want an introduction about the effects of the French Revolution. Then I want a description of what happened in the first 3 months, whatever. Like just tell the system what you really want. Don't let the system choose for you. If you tell the system everything that you want and are very specific, for example, by writing the beginning of the answer, you will get an answer that is much more surprising, hence much more difficult to detect. Also, if you write the beginning of the answer, you are allowing the system to see how you write. So for example, I said I use lots of likes when I speak, or I try to not do it when I write, but everyone has a certain style when they write. So if you allow the system to see how you write, it's more likely that it will pick up that way of writing and that it will just keep writing like that. So that's a great way to take advantage of those systems. Also, maybe consider using other LLMs. Like not everything is just ChatGPT. Like there's Claude, there's Bard, there's lots of them. There's also like Hugging Face Chat. You can just Google for that. There's a lot of LLMs. So just try to experiment with other things. Also, if you don't use English, it's better, because the detectors just, well, lose a lot of accuracy when you don't use English. You could also try changing some of the words for other things. So for example, like if you take a word and you switch it like into an emoji, it could potentially change the distribution of the probabilities in the text and confuse the system. Doing these types of changes that you see in the table could potentially change the detection of the detected text. And if you want to rewrite your text, I'd say that you should probably focus on the start of the text, because it's just a simple reason. It's because it's computationally expensive to analyze the whole text. So if you have like 500 pages and you try to run that through like, I don't know, DetectGPT or some of those tools, it's very expensive to do. So usually the systems that detect generated text just scan the first two paragraphs or the first paragraph, and they assume that if the first paragraph looks generated, then the rest of the text has been generated. Otherwise, it's human. So if you rewrite, I'd say that you should probably try to focus on the first part of the text. It's not necessarily the case all the time, but many systems take like this little shortcut. So I'd suggest that you focus on the start of the text. And the last tip is that just try to see if it looks generated or not. So like you just go to a website like this, you check if it looks like AI. It looks like AI. Okay, I have to keep rewriting. And those are the main things that you could do to, well, just use AI without getting caught, you know? Having said that, I'd love to have a final note on the fact that it's gonna get harder to detect this text over time. And what I mean by that is that as these models improve over time, the text will look, well, more human and more human-like all the time. So it's going to be much harder to detect. Bottom line, you might be able to detect your text, especially if you apply watermarks, etc., etc. But this thing of detecting AI-generated texts is really hard, and it's going to be a problem in the future. So that's where the talk ends, but with a lot of open questions regarding ethics, like what should we do about this, etc., etc. I don't have time to go into that. It's a really interesting topic, just too broad to cover. But I'd love to leave you with something, which is a QR code to rate the session. So if you like the session, I'd really love it if you could give me some positive feedback. I really appreciate it. And if you have things that you think that I could improve, that's also very helpful, because I always look at all the comments here, and I try to take them into account for improving other sessions. So I'd really be super thankful if you could just take like 15 seconds. It's super short, like really it's 2 questions, and just give me like, and well, what you thought about the session. Also, I should mention there's a surprise when you submit the form. So like when you click the submit button, there's, well, a little surprise there. So that's, well, just to encourage you to fill in the form. And having said that, I would love to give you some pointers for, well, some things you might want to read about if you're interested, or just message me. I'm super happy to speak about these things all the time. But having said that, I'm gonna say goodbye for now, and I hope to see you at another session. And I really, really wish you a super great conference full of fun stuff. So goodbye and see you soon.